Okay.
Turner
What's up?
was afraid. No, never.
All right. So first off, we're gonna do the homework, and then we're gonna revisit our Hearthstone thing with some JSON stuff, and then incorporate that into our data structures. So if all of you want to, if you go to Blackboard on the left-hand side, there's something that's called json.hpp. Just go ahead and get that file downloaded to your computer. That's what I'll be demoing today, which will allow us to work with that JSON file. And then also, as Jonathan posted in Slack yesterday, and then he just posted in chat here, if you want to attend the hackathon this Saturday, which all of you are required to do, minus, or there will be an alternative assignment. It's 8:30 a.m. to 8:30 p.m. this Saturday. You have to sign up before 7 p.m. this Thursday. He gave you a link. I would encourage all of you to go take a minute and sign up right now to make sure you're on the list so that he can make teams and things like that. Because I presume there will be a couple people from this class who will end up being team leads, and I think that they're still in need of those. All right, so with that being said, let's go ahead and just finish up our binary search tree with visit pre-order and visit post-order, which was your assignment for today. We wrote visit, well, we wrote the basic tree last time, and then visit in order. And then we'll go and look at the JSON stuff. All right, so let's jump over here. Hide this. Coming back to that. So let me just close both of these for right now. Oh, there's our binary tree. All right, so here's our binary tree HPP. So we're going to add a couple more functions here. Visit pre-order, visit post-order. Well, actually, I'll just copy from the other screen. So we'll come over here. I'll actually take this guy as my template. And we're going to write visit pre-order and visit post-order. For visit pre-order, it says that we will visit ourselves first. Then we'll visit our left child pre-order, and then we'll visit our right child pre-order. So that's what pre-order says. It says visit ourselves first, pre, then the left pre-order and the right pre-order. Similarly, post-order says we will visit ourselves last, and then we'll visit our left post-order and our right post-order. So that should be the two functions for the homework assignment under driver. So there's our visit in order, visit post order, visit pre-order. All right, and we'll go ahead and compile this. Actually, we'll just do star CPP. I don't think I saved it. Yep. There we go. I probably want to kick it down a line. It looks like it has it right. There's the in order. There's the post order. There's the pre-order. Okay. I could always do a little kick it down the line in me, you know, in those guys. So maybe at the end of all of these, I do a little see out. Maybe we do that before and after, kind of give a little bookends for all of our visit functions to kind of set it apart so we can see them. Oh, but that's still, we need to do it after the fact. Oh, whatever. I'm just going to leave it. I could sit there and try to format it better, but it's visiting in the right order now. Since this guy calls itself recursively, I'm, you know, putting all these asterisks and stuff in and kicking it down a line each time. I want it to look cleaner. I can always do this. I did take it out of all of them, didn't I? No. There we go. I'm still not kicking it down the line at the end. There we go. All right, so that's pre-order port or in order, post order, pre-order. All right, questions about that? So that should have been pretty straightforward. And again, like I mentioned last time, these make pretty good test questions. If I were to show you a tree and ask you to tell me what the order we would, what the order would be if we visited in order, pre-order, post-order. You should know how to traverse a tree. I'm not talking about writing the code necessarily for that, although we just saw the code wasn't difficult. I'm saying you should understand what it means to traverse in order versus traverse pre-order versus traverse post-order, and be able to write down the order in which, if I gave you a tree, you would visit those nodes. All right. That being said, let me go ahead and push this. Right. All right. So now we want to go and revisit our Hearthstone code. So I'm going to go back in here. And just to remember where we left off, we were creating a stack of, well, we created our stack data structure in here initially. And then messed with like insertion sort and things like that. And also we also had our linked list written in here. So we had some different data structures that we built inside of this guy. But if you remember, I'm going to go ahead and gut some of this. And we're going to return it back to a state that we had a while ago. I'm actually going to get rid of all of that stuff. And then I'm going to get rid of this. Get rid of that. Let's see, we had an assignment that started off noticing where the front and end of our JSON object was. But rather than write that ourselves, which wouldn't be horrific, we're going to end up using a library for JSON and then incorporating it into some of our data structures that we've written. Okay, so I'm going to also take out this line here and this line here. So we had previously created a URL HPP where we could build this guy by passing it a string to a URL that asked it for its contents. And then that hit the internet and went ahead and downloaded all those cards from this endpoint. And we would get it in a string format. So let's go and test that real quick. Just make sure we've returned this to its state where we're getting a wall of JSON comment in string format. We'll say G++ star CPP. Oh, we were linking curl into this. So we need to do our /compile. I think I have it in there. Okay. So now it's compiling that by linking curl And remember, the curl library was to get a remote URL. So now when I run this, we get our JSON string from the internet that we can kind of look through that and get an idea of what's in there, but certainly it's not overly convenient for us. We want to be able to get that information out and put it into a different format. All right, so any questions about kind of reverting back to this starting point? Oh, and also, before I forget, on class for Thursday, we're going to have a lab related to this. That's the day I have my stress test over at the hospital. So, and that's during class time. So we won't have class on Thursday where I'll be live, but we will have a lab during class time. And depending on what the lab is, I may either have it due by the end of class or due by the next class, or it could be a little bit of both. Where some of it is due by the end of class, and then there's like an extension homework assignment after that. So I will look into that, but we won't meet on Zoom or in person on Thursday. Okay, so let's go now and look at a JSON example. So the file that I gave you online is this gigantic HPP file. Okay, I did not write this. It has all the licensing stuff here at the top. So it is open source under this MIT license and stuff like that. So we're allowed to use it. You know, but you can see there's a lot of stuff in here. And this is actually an interesting implementation, because what they did to make this easier to use, which is maybe a little bit counterintuitive based on the normal C way of doing things. If you look at all the code we've written so far, we typically put our prototypes in the HPP file, right? And then we implement it in the CPP file. In this case, what they did is they put just everything inside of the HPP file. Because remember, I'll just go into, I think I have what it's called, test Json example. When I have something like include JSON HPP like this, and I put the double quotes around it, which says look in my local directory for that stuff, all it's doing at compile time is taking this line and replacing it with the entire contents of this. All right, so nothing says you can't put implementation stuff inside of an HPP file. In fact, nothing even says you have to call this HPP. You can call this guy .lol if you really wanted to. But typically when we think about header files, all it has in there are the headers of your things that this particular thing knows how to do. But in their case here, what they did is they gave us a single JSON.hpp file that had all the magic in it, so that in order to get this to work, in order to conveniently use JSON, which is really what we're trying to do here, right? We have a giant JSON string and we want to make it parsable so that we can do things with it. So with that in mind, they said, hey, just download this HPP file, include it, and now you have access to the stuff that's in there. Okay. So to work with this, we're going to, this is actually similar to something that we ran into in Python a couple semesters ago, where at least you probably saw it in the examples, where you can include or you can import something as like a local name. So we're saying we're going to use JSON as being equal to the information from this nlowman JSON library. So it makes us able to just say JSON whatever locally, and it's actually referring to this. Makes it easy to use. All right, so a couple of examples here. So we're going two different directions here. On one hand, here is actual JSON. We've just hard coded some JSON. So I'm creating a variable called JD employees. It's a variable of type JSON. And it's going to be equal to, this is an actual JSON entry. It's not a string. This is pure JSON. All right. We're going to be working with a string. So we're going to go on the other side. I just wanted to give you some examples. All right. So here's a JSON object. This JSON object has inside of it actually multiple JSON objects. So we have a list of, well, we have an object that contains our employees. This employee has a first name named Sean, a last name named Brown, a student ID with that number, and a department with that information. This is actually formatted a little bit funny. I probably would not have made these individual objects, but it doesn't break anything. All right. And then to access the individual values, now that we have our JSON object, we can just get that object and ask for a value, the value of first name. And this is the default value in case it couldn't find it. So in this case, the value of first name should be Sean. The value of last name should be Brown. The value of student ID, the default would be 0, is going to be 21453. And the value of department should be computer science. So whenever we get the value from something, we can always give it a second parameter that says, if you can't find it, use this as the default value. And that's actually going to be somewhat helpful for us, because if you go back here and you see, if you remember when we looked at this originally, not all of the entries have all of the different information in them. Okay, so some cards are spells, and if it's a spell, then it wouldn't have a number of hit points and a number of damage that it can do. So some of these cards wouldn't have those things. So you would want to get default values for the situation in which a card didn't have that information. All right, so this is an example of creating a variable of type JSON and then extracting values from that JSON. We are not going to be doing this because we're going to be getting we're going to be parsing the string that we got online, this guy, into a JSON object. So we will still be using these examples, getting the value of something from a collection of JSON objects, each of which represents our cards. But we won't be hard coding a JSON object like this. Instead, we'll be getting our JSON object from a string. All right, so what I do here is I extract those values, prove that we were able to extract them, and then I dump this thing out to a string. So jdemployees.dump turns this JSON object into a string representation of that JSON. All right, so let's go and look at the output of that, and then we'll start merging these two ideas together. So I'll do J++, Json Example. All right, so that guy compiled, and then I'll do a.out. So here is here is evidence that we extracted individual values from our pure JSON. And then here is our JSON object output to, well, this is from when I changed the size of it. I promise it looks better than that. There we go. This is our .dump of that JSON object showing us the output. And it actually looks like the reason it had to do, if we go back in here, I said it looked funny. If you're going to hard code in a JSON object, you have to use the format that C++ supports. So it actually needed to put them, these guys, this is a hard-coded array to create our name value pairs. All right, so I would actually say that creating a hard-coded JSON object like this is actually going to be somewhat inconvenient. All right. So what we want to do is, assuming we have an object like this and we have it in string format, so let's go ahead and get that in string format. We're going to go ahead and let's see. Well, here we'll go two different directions. So now I'm going to say string JSON string is equal to this guy. All right. Now we can pretend that that guy right there is the same kind of thing that we're getting off the internet with all of our Hearthstone cards in it. All right. So we have a actual plain Jane string that just happens to hold characters in the format of JSON. All right. So now we want to parse that. So we're going to say JSON parsed JSON is equal to JSON dot, is it JSON parse? It's JSON dot parse JSON string. I think I'm using that correctly. Let me just test that real quick. I'll bring it up in here just so we have the documentation for it. So it'll show us the GitHub repository for this guy. So this is actually the GitHub for it that has all the code in it, but I've just gone and grabbed just that header file, which will allow you to mess with it. But down here, he has a README file. And let me just get an example. Oh, it's Json Parse like that. Okay, so we don't have any output yet, but it did parse it. So after this is done, we'll have our parsed JSON object, which is the same kind of animal as this guy was, our JD employees was. So now to prove this, what we'll go ahead and do is I'm going to just print this stuff out again. So we're kind of doing the same thing twice. And what I'm going to do for first name, I'm going to steal the examples from up here, but we're going to replace it with our parse JSON object. So this will be last name. This will be, I'm guessing it's student ID like that. Capital S. And then department. And the default value for student ID was 0, but we're not getting any of the default values, so that's fine. Okay, so we got the string version of our original JSON object. So this was in pure JSON. Then we converted our pure JSON into a string. Then we used the JSON library here to parse that string back into a JSON object. Now we're going to prove that it was indeed correctly parsed because we're going to have the ability to grab values from that parsed JSON. Okay. So there's our second group there. So we went from JSON to grabbing values from JSON directly. Then we took a string version of JSON, parsed it into a JSON object, and then asked that object to give us those same values. All right. So we've kind of seen both ways. And the common way we're going to digest this in let's say the real world is you will almost always get a JSON string like this and need to turn it into a JSON object that you can then extract values from. The only time you would use the dump command, well, let me ask you this. When would you use this dump command? When would this be handy in modern day software development, let's say? If I have a JSON object that I've been working with and I've made changes, whatever, when would it be helpful for me to do a dump of that JSON object?
Would it be helpful if you're looking for like one specific thing?
Well, what does this guy ultimately produce? That produces a string, right? So I have my entire JSON object now represented as a string. Now, what makes strings convenient? What's nice about strings as opposed to an object?
You can split the string.
Okay, I can manipulate strings. That's for sure. When I go back here and I look at my output up above here, what was all this? Wasn't this a string that was sent to us over the internet?
Basically, yeah.
Exactly, it was. It happened to be in JSON format, but it's the type of value it was of string type. So strings are something that we can send to other programs over the internet, for example. An object cannot be done that way. So if we want to send objects, we want to talk about serial deserialization. Serialization. We're going to flag this as Json serialization. Is the act of converting a JSON object into a string for convenient transport to a new destination. We're going to say usually over the internet. So if we think about the source of our example over here where I have my driver. Where's driver? Oh. So when we look at this guy here, this API, Hearthstone, J, blah, 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 and we ask it for this, we are asking it to send us some information. Now, this is actually not a traditional API. This guy just is literally a file that lives on the internet. We're downloading the file, but let's pretend that api.hearthstonejson.com had an endpoint that was like /get current cards. So instead of this, it was called get current cards. All right. And this would be a computer program that lived at this web address. And when we called it, it would go ahead and process this, and the output of that program would be a string that then gets sent back to us over the internet that would look just like the string we're getting directly from this cards.json. So this is kind of a pre-generated output. So instead of it doing it dynamically every single time we call the API, I don't know how often they're updating this, but maybe it's a once a day thing or something like that, where they go ahead and they regenerate their cards.json file so that people can just download that file. But it doesn't really matter. The point is that we are hitting a website, and that website is giving us organized information in the form of a JSON string. All right, and that's what we're getting inside of our program, is that JSON string. If we want to be able to use the contents of that JSON string, we then need to parse it using a Json parser. Okay, that would be called deserialization. So this is the act of converting a string into a JSON object that we can then conveniently extract information from. And to kind of close the loop on that, even though what I'm looking at here, even though we can visually see as a human being that there's a lot of information being represented there, this format, this string format of just a wall of text, is not convenient for us to extract information out of. It's convenient for us to send this information from point A to point B. Right? I can just bundle everything up in a big old fat string and just say, here's this giant string, do with it what you want. That's effectively what we've asked this website for. We've said, give me a string representation of all your crap. But once we have that, it looks all pretty to a human being because we're smart and we can kind of glance at this and see, oh yeah, there seems to be some patterns to this, some formatting to this. And maybe as a human being, we can kind of glance through it and figure out how to split that stuff apart visually. You know, I can kind of look at this guy and say, oh, the artist of this card is this dude. The card class is neutral. Its cost is 0. Here's some database ID. You know, as a human being, we can kind of start picking out pieces of information, but we're not automating this process. We're not able to conveniently get this into our program because right now it's kind of like this giant chunk, which is just the string. But that giant chunk string was convenient for transporting this information over the internet from one program to another. All right, so we can say something like, serialized data is convenient for transport between programs. Today, this might be commonly done over the internet. All right, so we want to send structured data over the internet. That's going to be a common occurrence. So let's say you are on your smartphone and you go to the weather.com app. Well, chances are that app is sending a request to the weather.com servers and saying, what is the current, so actually I want to give you an example for this. Example, weather.com app. I don't know if this is going to be exactly the example, but it's going to be something like this. This will close our loop for this. So when we open the app, I'm going to do this in a separate slide so the font doesn't get too small. when we open the app, we give it our zip code. For example, whether it figures it out based on location services or we have to type it in, doesn't matter. It has our zip code. Then the app makes a request to the weather.com API server in the cloud. This request is likely made in the form of a JSON or a serialized string. So if we ask for hourly weather info, that string might look like type hourly location 53024, something like that. This might be the string that we're sending that's being sent from the weather.com smartphone app over the internet to the server. All right. So this is requesting hourly data. So this is structured information. So that API at weather.com is going to receive this string. It's going to piece it apart and it's going to say, what are they asking me for? They're asking for hourly information for this location. The server then processes this request. Well, the server processes this request by parsing the string. We're going to say deserializing the string into an actual JSON object that can be conveniently queried and does the magic of getting the current hourly forecast for 53024. The server then serializes that data and replies to the app that requested it with a JSON formatted string. This is a serialized string that can then be parsed by the weather.com app and conveniently queried to show the hourly forecast on the app screen. All right, we see this kind of back and forth. If we have two different computer programs that are trying to communicate with each other, we're going to kind of send a little note to each other. You know, it's kind of like, passing notes in elementary school or something like that. It just so happens, though, these notes are in the format of JSON modernly. We have to have JSONs are our modern way of representing structured data. All right, but all it is a string. Okay, at the end of the day, JSON, the way JSON is structured is just a string that follows a specific syntax with just name value pairs. So we send strings between these two computer programs. And when a string is received, it gets deserialized into a JSON object that can then be used. And when we want to send information, we serialize a JSON object into a string that can be easily sent. All right, that makes sense. The two-way communication where it's easy to send strings between software applications, but not necessarily easy to send objects. So why serialize and deserialize? We want computer programs to be able to communicate with each other. Instances of objects are not convenient to send across, or to send, let's just say, to send between running programs, regardless of where they're located, whether it's two programs running on the same computer or it's two programs running on different continents across the internet. Doesn't really matter. These two programs really can't send a initialized or an instance of an object between them. All right, because that's a local memory address where that actually lives, things like that. All right, so we need to have a mechanism for packaging up info to send to another program, as well as a mechanism for unpackaging info when it is received from another program. All right, makes sense, this whole idea of serializing and deserializing. Now we can certainly write our own software that does the serializing or deserializing. And historically, I think we've talked about this before, but let's just close the loop on this idea. So how is this done historically? So maybe we had comma separated value files. For example, Excel can export a spreadsheet as a CSV file, so it can be easily transported and imported into a different software application that knows how to parse a CSV file. Maybe a little bit more modernly than that, we maybe would have used XML files. So this predated JSON and followed a tag-based standard similar to HTML. And then JSON files are a more programming, well, let's see. JSON files solve the same problem, but look a bit more like code and have less verbosity. That seems like it's a word. Emily, is that a word?
I am the wrong person to ask. I barely know what a word is. And also your Mac is about to die.
My Mac's about to die? Oh, thank you. We're fine. I'm right next to my plugin. I just forgot to plug it in. I think verbosity is a word.
I just searched Google and it is a word.
Ah, perfect. All right. we're plugged in. All right, so JSON solves the same problem as all these other things, but it looks a little bit more like code, and we want to consider that code is the people who are probably sending JSON and receiving JSON are probably programmers, right? You know, if you're sending an email to your buddy for your buddy to read directly, you're probably not formatting it in JSON saying that, oh, a human being is going to be able to more conveniently read this. This is a good format for them to just sit there and browse, right? We're going to put it in a more user-friendly, maybe the bulleted list or something like that. All right, so typically the people that are going to be working with JSON format are going to be programmers. So packaging stuff up in a code-like file with that's less verbose, fewer characters to represent the same data. And this is as opposed to tends to be very verbose. So XML represents very little data in a whole lot of characters because it's using these tags before and after the thing. So there's, you know, call it 90% of the text in an XML file is metadata that's describing the data that's between those tags, not the actual data itself. Where JSON is at least less extra symbols and stuff to describe the data. All right, but punchline here is that when we have two computer programs, wherever they are, regardless of where they are, and we need to get data between them, creating a structured format is handy because we can't export a memory address and just send it between the two of them. Okay, because those things might not be on the same computer, and therefore knowing where something lives in memory might not be handy. All right, so JSON tends to be our current cool kid for packaging up structured data so that it can be unpackaged on the other side and something can be done with it. All right, any questions about the rationale behind these things? Okay, so let's go back over here now and let's marry these things together and receive this string and turn it into a JSON object. So here's my JSON example. So up top here, I'm going to need to include, actually, I'm going to grab both of those lines. All right, so we're going to include our JSON HPP. We're not using all this stuff right now, but we'll, we're using card, we're using URL. I don't think we're using my functions. We're not using stack. We're not using time. I think that's everything. Let me just make sure that still compiles before we do anything else. Yep, we're still good. All right. So now I've let my driver.cpp know about my JSON library. And now what we want to do is we want to parse our JSON here that's coming in. So this guy is a string. So we'll say string JSON string is equal to U1 get contents. So now I have that string. And then we're going to go ahead and create a JSON object called parse JSON. And that's going to be the parsed version using our JSON library of this JSON string. All right, and let me go back here. That's dot value. So this seems to be the stuff that's in there. I think it's going to be an array that we're going to get because we've looked at our data here. And if you remember, if I scroll up, it ends in a square bracket. So JSON supports arrays. So this is going to be a comma delimited set of stuff. So I'm pretty sure if I do array here, well, I wanted it to show me the let's see. Nope, I think that's, well, actually we could do this. We can do cout parse JSON is array and del. And this guy should give us a 1. This is going to return a Boolean. Dot is array. This guy returns true if it's array, false otherwise. But bools are represented as integers, and actually it might show a true or false in C++, but I think it's going to give us a 1, not a true. But we happen to know that our data that's being sent here is an array, and this is going to be our initial proof that we successfully parsed it into a parsed JSON object, because then we're asking that parsed object, are you actually an array? And it should tell us, yes, I am.
I have a question.
Sure, go ahead.
Why is that a dot instead of an arrow?
This is a dot because this is not a JSON pointer. It's not this.
Okay, thank you.
Yep. Because remember, the arrow is the same thing as saying star this dot. You know what I'm saying?
Yes, thank you.
Okay. All right, so let's go ahead and run this dude. So we're gonna do our G++ driver.cpp. Oh, we also need to get our, well, I'm just gonna do url.cpp as well. I only want to do these specific ones because I have more than one program with main in it inside of this folder. So if I try to compile all of them, it's gonna get confused on what do I actually, what is a.out actually call? Do I call my Json example main method, or do I call my driver main method? Oh, and then we need to link curl. Doesn't my compile have that in there? Wow. Show curl. All right. We should get a true out of this, or a 1, that it was a JSON array. Okay. So far, so good. So now we want to actually get elements from this array. So we can ask a question. We can do something like, if this guy is an array, let's do some stuff. So what are we going to do? We're going to say for int I is equal to 0, I is less than parsed JSON dot count I plus plus. Looks like this is a function.
arrow instead of dot?
Nope. Shouldn't be
Okay.
an arrow. Because parse JSON again, this guy is a not a pointer. He's an actual object. So it looked like count did not give me, count gives me a, I have to give it a key. So let's see. I can find stuff. What? Oh, maybe get. Or is it length? I'm just searching through the things in here rather than going and looking at the header file. I just want to get the items. Is that going to tell me maybe the thing? Nope, that gives, well, that does give me an iterator, but that's not what I'm looking for here.
There was one called max items or max size. I don't know if that'd be right.
Yeah, I'm guessing max size is the maximum number of things that can be in there. Ah, looks like size.
There's a size.
Yep. All right. So for int I equals 0, I is less than parse JSON dot size, I plus plus. So we're going to go through all of the elements. Now I'm pretty sure, I'm just going to cheat here real quick. I'm pretty sure every card had a name. I think every card has a name. But it doesn't matter because we can give it a default value. So we're going to go ahead and we're going to say JSON per value is equal to parsed JSON dot get I. No, that just gets a individual. How do I get a value? Is it just, can I get it like that? Oh, like I can. So JSON cur value equals parse JSON I. So now I'll have that guy. And then we're going to go ahead and say string name is equal to cur value. And I just want to make sure I'm using it dot value, right? Dot value name. And was it in lowercase or all caps? Lowercase. And then I'll have n/a as my default. So I'll go ahead and, so this will give me the, this is a collection. We're only in here if parse JSON is an array. So I'm going to go through all the elements of that array. I'll grab the current element of the array, the one at bucket I, into cur value, which is still a JSON object. So this is either a JSON array or a JSON object. In this case, it's a JSON object. I just happen to know that's the case. I could ask the question. I could say if cur value dot is object. Then I can go ahead and grab the string. That is the name. And then I can do like a cout name and del. Something like that. So hit my API, parse the string. If it's an array, go through all the elements of that array. For each one, grab the next JSON object. Ask the question for no good reason, probably, if it's an object. If it is, extract the name of that particular card, or NA if it couldn't find a name. And then we're going to output that name. So our hope is, assuming we've done this right, this is the question mark here, is that the right way of grabbing elements from our JSON array. Doesn't seem to complain, so it at least thinks that's legal, legal syntax. So the hope is when we're done here, we should just get a bunch of printouts. I don't remember how many of these. There's like 5,000 some odd cards, I think. We can actually output the, well, let's just run it first. We should just get a whole bunch of card names out of this. So there is a whole bunch of card names showing that we were able to break our JSON into a bunch of cards. And if we want to see the number of cards that were there, we can steal that real quick. And we can say cout number of cards. That guy. I don't remember exactly what the number was, but it's a big number. $5,217 cards. Looks like there's some duplicates in there too, though. Maybe there's different versions of that same card or something like that. All right, so now we've gone from wall of JSON to actually being able to pick out individual cards here. Now remember, we had our card HPP, and our card HPP took in a name, a mana cost, an attack, and a defense for building our cards. And then they knew how to display themselves. Let's see, because we're doing a lab next class, let's go ahead and just do this. I'll set us up for that lab and then not give homework for next class. Yeah, and then the lab will have the lab be an in-class thing only because I'm not going to give homework over the weekend because of the hackathon, unless you have to do the penalty assignment. Okay, so we're good. So what we want to do now is we want to go ahead, and now that we're able to extract a name, we're going to go ahead and build cards out of this guy. So I'm going to go ahead and I'm going to say I need a, am I already importing card? Yeah, I'm already importing card HPP. So I'm going to say I need a card pointer named the cards. And there is going to be this many cards in there. All right, so that's our card array. Then what we want to do is we want to build a card, like I just showed you. We need to pass it four pieces of information. Its name, its mana cost, its attack, and its defense. And just so I can piece this stuff out here real quick. Actually, let me just do this.
I have a question.
Sure.
Wouldn't that card pointer that you made be one individual card instead? Wouldn't you want like some kind of like deck or something?
Maybe eventually you would, but isn't this an array of card objects?
You're right. I didn't see that. My bad. Never mind.
This just points to the base address of this guy. But you're right. We probably would want to have a deck of cards or maybe a stack of cards, that would make sense for building a deck, right? All right, so let's see. What were my, well, I was gonna go in here. All right, so I have a name. I have a what are my other pieces of information I'm asking for? Mana cost, attack, and defense. So what's mana cost called? Well, attack is all lowercase. So we can go grab that. And what kind of value is that? It's just an integer. Int attack is equal to cur value dot value attack, or I'll say -1 if it doesn't have an attack. Int defense is equal to cur value dot value. We'll have to look at what the name is. And this is not how you spell defense. There we go. And then the last one is mana cost. Int mana cost is equal to cur value dot value. Again, whatever it's going to end up being. I'll go ahead and put a -1 there for mana cost as well, but I think every card will have a mana cost. And let's go find defense and mana cost for these guys. Maybe it's just called cost. Or yeah, it's just called cost for mana cost. And then defense is called health. All right, so we have our 4 pieces of information now. And we'll go ahead and say the cards at bucket I is equal to a new card. And our card constructor says it wants a name, a mana cost, an attack, and a defense. So we'll give it our name, our mana cost, our attack, and our defense. So we'll go ahead and add a card to that array. And then we'll prove that it worked by saying the cards at bucket I display. All right. And again, the reason I use an arrow here is because the cards is a pointer. So I'm saying, give me the address of the card at bucket I, and then give me the value that lives at that address, and then call that values display method. That's that difference between dot and the arrow. So now I'm going through all my JSON for each element, each JSON object in my JSON array. I'm going to ask the question if you're an object, just in case there's some broken JSON in there, I guess. So for every object I run into, I'll go ahead and grab the name, the attack, the defense, and the mana cost. And I presume these are all coming out as integers. And then I'll go ahead and build a brand new card object using my card class we had previously written. And then I'll ask that card to display itself in whatever format we did. Hopefully it looks at least decent. All right, all that's saved. So now to compile this guy, I also need to throw my, this actually should be URL HPP, and this should be card HPP. Card is not, did I not write display? Yeah, it has a display. Oh, I'm compiling here. So these should be CPPs. Sorry. So here are, this is the output of my display method for, see, actually, this is interesting. Some cards didn't have a cost, but if we scroll up here, we should find several that do. So here's Golaka Crawler, cost of 2, attack of 2, defense of 3, so on and so forth. All right, so makes sense? So we did quite a bit today in that in the end, what we did is we took our JSON string and we started pulling actual information out of it using our JSON parser. All right, so you're going to need to use this on for our lab on Thursday. So I'll go ahead and push this code, but make sure you wrapped your mind around using this before your lab on Thursday, because you will need it, and the lab will be due by the end of class, because I'm only giving a penalty assignment over the weekend because there is the hackathon. And again, if you haven't signed up for the hackathon, go sign up as soon as possible, please. All right, questions, comments, concerns, bribes. All right, I'll see everybody. Well, I'll see you at the hackathon at the very least, and I'm around on Thursday, just not during class. So if you need to get on Zoom or something tomorrow or Thursday, I'm happy to help. All right, talk to you later.
I have a quick question.
Sure, go ahead.
So when my Ubuntu install, I had to redo all that.
Yep.
I need to reinstall curl. Do you remember the command for that, just like off the top of your head? If you don't, I can find it in the previous.
No, I got it. So it's apt-get. I usually do an apt-get update, and you want to do a sudo before that, just so you have the latest stuff. Sudo apt-get update like this.
Okay.
And that just make sure you have all your current packages, and then you'll do sudo apt-get install curl.
Is it just curl? I thought there were like a couple different things like curl.
Actually, it might be like curl lib.
Okay, that sounds right. Okay.
Here I can history grep curl. This guy, actually, that's
what?
this guy right here.
Okay,
Or this guy right here. I think it was libcurl4.
And is it just that, or is it that and curl something else?
Let's see. I think it's, well, if you do apt install curl or sudo apt install curl, and apt is a shortcut for apt-get. They'll both work. So I would install curl and then install, it looks like we did curl, libcurl-dev, and libcurl4-gnu utils dev. So it looks like these are the 3 things that we did. Sorry. This one, and this one. And you can do them all in one line if you want. You could just say install curl space libcurl-dev space libcurl4-gnutls-dev.
Perfect. Thank you so much.
Yep.
All right. Also, I'm getting my second COVID vaccine tomorrow.
Okay.
I'm really hoping I don't have any side effects or anything.
That's fine. Just let me know, and I can make your lab do later.
Okay, perfect. Thank you so much.
Yep.
Bye. Good luck at the doctor.
All right. Thank you.